So again, pardon the noise. Remember that we were going to talk about these 4 exam problems, the related concepts, and some relevant homework problems and some other information you might want to know. So, wrong button. Okay, so here's an example problem, and I want you to stop the video and try this, and then listen to what I have to say about it. So, suppose you roll a die 100 times, and you get these results. What is the probability of rolling a 4? Well, that will be... Oh, whoa, sorry. Okay, so this thing is not cooperating. Rolling a 4 is 17 out of 100. And if you want to write that in decimal notation, you get 0.17. That's it. And the reason we know that's correct is because there were 17 times a 4 came up, and there were 100 trials. So now ask yourself this, and stop the video before you proceed. Is this experimental or classical probability? Or maybe we call it empirical. I can't remember what we call it in this text. But this is definitely not classical probability, because we're not basing the probabilities on the 6 possible outcomes in the sample space. We're basing this on the number of times a 4 appeared divided by the total number of trials. So that's definitely an empirical probability, one that we observed. Okay, so here's the answer. Now we'll look at percent versus probability. So we have a problem here. According to the American Veterinary Medical Association, the percentage of households owning a dog is 37.2%. What is the probability that a randomly select household owns a dog? So now don't think about this too hard. You might be like, well, isn't it right there? But the text wants you to express your answer in decimal notation, not percent notation. So remember that 37.2% means 32.7 divided by 100, and that's how we get that decimal number. Okay, there it is. Now let's look at some probabilities, and pay attention to these notes here. Make sure you have a simplified fraction, and I mean sometimes I noticed the homework asked for decimal notation. Sometimes it asks for a fraction, but make sure if you type in a fraction, it's in simplified form. And then remember this definition of an unusual event on page 257. So let's look at this problem. We've got a golf store that sells an onion bag. I don't know why it's called an onion bag. Maybe some of you play golf and understand that. I certainly don't. So we have 80 experienced golf balls. This sounds like a sort of a sneaky way of making them sound better even though they're used. So we have 35 Titleists, 25 max flies, and 20 top flights. What is the probability that a randomly selected golf ball is a Titleist? Same question, is a top flight. Would either of these events be considered unusual? Try this problem, stop the video, and then see what I have to say. Okay, so I'm going to work up here because I don't have a lot of space. The probability that a randomly selected golf ball is a Titleist should be 35 divided by 80. And now I know what you're thinking. How do I write this as a fraction easily? Well, factor. 35 is 5 times 7. And 80 is, well, I'll do this over to the side. I know that 80 is 2 times 40. And 40 is 2 times 20. And 20 is 4 times 5. Now I'm going to stop right here, even though 4 is not a prime number, because I see a 5 times a 4 times a 2 times a 2, and I know that 5 divided by 5 is 1, so I know that the simplest form is 4/8/7/16. So if you need to see that again, just rewind the video. Rewind, I'm dating myself. And if you have a question, follow-up question about that, ask me about it. I'd be happy to go over that technique again. So this is 7/16. Now you try this one. Okay. The probability that a ball is a top flight, if it's randomly selected, should be 25/80. And we don't have to factor 80 again. We already did that. 2 times 2 times 4 times 5 over, and then the numerator is 5 times 5, so we have 5/16. Now, would either of these events be considered unusual? Well, remember the definition our book uses of unusual is less than 5%, less than 5 out of 100 times, less than 0.05, however you want to say it. So now at this point, it's reasonable to get out a calculator. 7 divided by 16, that is less than, no, that's like almost 0.5, so we would not consider that unusual. A, not unusual. Probability titleist is greater than 0.05. And I'm sorry my writing is so sloppy. B, let's do 5 divided by 16. 0.3125, not unusual. For the same reason. Probability of top flight greater than 0.05. And here are the answers typed up. Okay, let's go. Now we have one more problem. We're going to do a compute OR probabilities, and then I will switch this video off and we'll start a new one. All right. An experiment is conducted, and the resulting sample space is this. These are all the possible events that could happen. Here's an event E, here's an event H. List the outcomes in event E or H. Find the probability of E or H by counting the number of outcomes in E or H, and determine the probability of E or H using the general addition rule. All right, so let's start with part A. What are the outcomes in event E or H? So things that occur in E or things that occur in H, but we don't count repeats. So we can describe this as a set with the little squigglies. So 1 is not in either of these sets, so we don't count 1. 2 is in both, 3 is in both, 4 is in both, and 5, 6, and 7. So that's the event. Those are the events E or H. So if you belong to E, you're in this collection. If you belong to H, you're in this collection. If you happen to belong to both, good for you. So now notice that the probability of E or H is the number of things in this collection, which your book uses this notation, divided by number in the sample space. And excuse my terrible notation. And so there are 6 events in E or H. And let's see, there are 12 events in the sample space. This is 6 times 1, 6 times 2, 1/2. So that's the probability of E or H. Now, I'm not going to be able to fit part C on here, but, well, actually, no, I don't think I can. So I'm just going to pull up the typed version. And I don't think you can see that very well. So actually, let me just pull up. I'm just going to go back a page, because I think I can fit it. No, let me just put it here. I hope that's not too confusing. So just ignore this, and I'm going to write the probability of E or H. And that's the probability of E plus the probability of H. But do you remember how E and H had things in common? If you compute this, you will get a number that is much too big. So if you subtract the probability of E and H, you will get the right number, because when we did the probability of E plus the probability of H, we counted the things in common twice. So we subtract off one of those, and then we get the number we want. And then the probability of E, I don't know why I keep doing that, is, where is it? Probability of E is 6 things, 12 total, 3 ways to get H, and there were 3 ways to get E and H. And notice that plus, that's a plus, not a minus. Now I know what you're thinking. You should add first as you work left to right. Well, you don't really have to. These cancel, and you're left with 6 12s equals 1/2. So it works either way. So on the next video, we'll work problems 5 through 8.